Hey DIYers, and welcome to what I believe will be the first video in a series on interviewing in the development community. I think that it would be irresponsible for me to try and cram all this into one video, because whether you're front end, back end, anywhere in between, you're going to come across a lot of different ways of being interviewed depending on what kind of a company you're trying to hire on with, whether it's a tech company or an agency or a mom and pop shop or a freelance client. It's all different and it's all unique, and to be honest, even the tech companies are going to interview different depending on which tech company you're going for. I think there's three major scenarios you need to be prepared for. One would be just a code test. They may hand it to you beforehand. They may give it to you on site. They may watch you. They may not. The next thing that you need to be prepared for is just flat out questioning. They may want to see your code, so you need to be able to talk through your code. And the third is, whiteboarding. That's a whole different animal, because it's a lot different trying to write code on a whiteboard than it is with the keyboard. And it's something that if you haven't practiced or failed at a lot, it can be a little intimidating, and it can be hard to find the answer you already have and you could do if a laptop was in front of you, or if you were just not under that pressure. It's a way for them to see how you handle the pressure, see how you think on your feet, and see how many different ways you can solve a problem. And I really think, obviously I'm not the hiring person at Google or Facebook, but I think it's important for you to be able to solve a problem more than one way. And when I say that, it's not necessarily saying, okay, this is one way to solve it, and this is a whole different way to solve it. And maybe this is one way to solve it. Now let me break it down for you, and let me show you how I can simplify this and refactor this code a little bit. Like, that's a big deal, and not a lot of guys can do that, especially not on their feet. So being able to do that is a huge, huge, huge win for people, whether you're whiteboarding or code testing. If you can talk through what you think about the first solution and how you think you could do better, if you can write a solid piece of code, then refactor it, people are going to see that and respect that. That's a big deal in this community, and I think not enough people have that skill. So, I felt like the best place to start for all this would be to do a few code tests. And to be honest, I've had people ask, like, oh, hey, do you have any code tests you could think of that would be great? And I'll show you a website here in a second that has some great code tests, and they have a ton of them, and you can spend days and days and days trying to figure this stuff out, especially if you're new. So I figured it'd be fun to kind of just work through a few of those today, just to kind of show you how I'd handle certain situations. They're certainly not going to be the best answer. They're certainly not going to be the right answer, but it's going to be a way that works and solves the problem. What I'd like to see is other people posting their own versions of these tests for other people to see in the comments. And if you want to email them to me, I'll post them on the website, wherever. I think this is a good way for people to learn, and it's not just about code writing, it's about critical thinking, which is really, really important. So let's go ahead and get started. So let's open up, I believe it's projecteuler.net. So I'll have this link in the description, but we're going to dive right in with the first code question. So the first question states, if we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9. The sum of these numbers is 23. Find the sum of all the multiples of 3 or 5 below 1,000. So let's go ahead and open up our text editor here. So I'm going to go ahead and do HTML boilerplate, just so we have an HTML page to work with here. This up, desktop, new folder, tests. And we're going to go ahead and do one of these. Great. So this way we have access to this. Alright, so we're going to go ahead and get rid of that. Perfect. Alright, so I just went ahead and set up my workspace here a little bit, just so we have everything we need. So I'm going to go ahead and do HTML boilerplate. No, I think it's just HTML boiler. I got to save it as an HTML file first. So let's go ahead and save this. We go to desktop, and we're going to go into tests. We're going to call this test1.html. We're going to say HTML boiler. All right, so that gives me everything I need to just kind of make everything happen. I'm going to chop pretty much all of this out because I certainly don't care about Google Analytics for this. I don't care about anything in the body. Yep, so that should do it for now. We're going to throw, because I know that this will break, we're going to throw HTTPS on that. Then we're going to open up a script tag. Script. All right. So what we need, I'm going to go ahead and write this out so I can get rid of that window actually. So we're going to say if, or basically find the sum of all the multiples of 3 or 5 below 1000. Simple enough. So I can go ahead and close this now. We'll open this up and give ourselves a little more breathing room. All right. So the first thing we're going to need is a sum because we're finding the sum of all the multiples of 3 or 5 below 1000. So actually the first thing we need is an anonymous function. And basically this won't call until everything's loaded. So now that we have that, give ourselves a little breathing room. So we need a sum. We need to figure out the sum. So let's start out with a variable called sum, and we're going to make that equal to 0. So the first thing we want to do is a for loop. So we're going to say for I is equal to 0. The basic premise of a for loop is you give it 3 parameters. You give it the starting number, the reason to keep doing the for loop. So it would be while I is less than 1000. So while I is less than 1000, it's going to keep doing this loop. And then the last thing is going to be what increments. So if we do I++, every time the loop happens, it's going to automatically increment I by 1. That's what the plus plus does. So what are we going to do in here? That's the real question. So basically from here, we're going to check to see if each number that we iterate over from 0 to 999 is a multiple of 3 or 5. So we'll go ahead and start doing that by saying if I percentage 3 is equal to 0. And then we'll say or, which is 2 vertical bars, I percentage, you guessed it, 5 is equal to 0. And we'll go ahead and finish our if statement here. So what's happening here? Because this looks like gibberish to me. The basic premise is this. This is called the modulus. And basically what it does is it gives you the integer remainder of dividing these two numbers. So if it wasn't divisible, this would be some crazy decimal point or number with a decimal point. But if it's a multiple of 3, it's going to give you 0. So if the modulus of this number and I, which is going to be 0 through 999, is a multiple of 3, it's going to have a remainder of 0. If it's not, it's going to have some crazy number. Same thing with 5. So now it's simple. We say sum, and a lot of people are going to go, okay, sum is equal to I, right? Well, that would work for one iteration, but basically you would keep replacing sum. So every time this would go through, sum would become whatever I is. It would not become the sum of the numbers. So what we have to do is we need to put a plus in front of it. And what that does is it takes sum and adds I to it. Another way to do this would be to do sum equals sum plus I. That's another way to do it. But we're going to work with the shorthand here because this is cleaner. So that's all we're going to do. We're going to say sum is equal to sum plus I. I'm going to go ahead and step out of this for loop because it is done. So the last thing we're going to do, the last thing we're going to do is we're going to do console.log the sum. Save that. Let's go ahead and open this. Good to go. Nothing happened there because we just echoed it, or we just console logged it. So, wow, this is a lot of numbers. How do I feel about this? I'm not really sure how I feel about this. I think I messed up. So let's bounce back out of here for a second. And what did I do wrong? Well, it's pretty obvious, and I'm sure some of you caught that already. Let's go ahead and move this console. This is what happens when you write sloppy code. Tighten all this up a little bit. All right. So now what's going to happen is, instead of running that console log every single time the for loop went through, we're going to run it when the for loop's done. Now we have the sum is equal to 0. And then for every number between 0 and 999, we're going to say if that number is a multiple of 3 or a multiple of 5, go ahead and add that to the sum. Then at the very end, once it's looped all the way to 999, we are going to see the sum. Now that we saved it, let's go ahead and check it out. Let's see if it came to the number we were thinking. Well, to be honest, I don't have any idea what the number would actually be, but I feel like that's probably pretty spot on. So what's another way we could write this same concept, but in a different way? So let's simplify this a little bit. So we're going to do an inline if. I think it's got a different name. It's like ternary or something like that, but a ternary conditional maybe. I don't know. But the important thing is that it basically works just like an if statement for the most part. So let's go ahead and we're actually going to put that inline if into our sum variable. So we're going to say sum is equal to sum plus what? So we're going to say I percentage, and follow me here, this is going to be a little bit different. I percentage 5. I'm going to say if that's true, if that's false, make it 0. No, if that's true, make it 0. Otherwise, make it I. So here's what's going to happen. It's going to say, it's going to take I. Is it not a multiple of 3 and not a multiple of 5? If so, make it 0. Otherwise, add I. So what this is going to do is, if either of these are false, it's going to automatically add 0 to the sum. If it's one of those is true, so not both are false, it's going to take that I and add it to the sum. So we should, in theory, get the same number. Let's see what we end up with. Let's go ahead and reload. Inspect element. And boom. It's a much shorter hand way of getting to it. I think we'll go ahead and save that, test 1. I'm going to say, we're going to create a new file. We're going to say new. Call this test2.html. Let's go ahead and save that. So let's look up test2. So it's going to be project Euler.net. Okay. So project Euler, we're going to go to the archives. We're going to do, even Fibonacci numbers. Woohoo! So each new term in the Fibonacci sequence is generated by adding the previous two terms. By starting with 1 and 2, the first terms will be 10. Oh, I'm sorry, the first 10 terms will be 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. By considering the terms in the Fibonacci sequence, those whose values do not exceed 4 million, find the sum of the even valued terms. So we're going to do, basically we're going to copy all this again, and we're going to get rid of everything in our function for this one. We're going to put a new comment here, and we're basically going to say we want to find the sum of all the even valued terms in the Fibonacci sequence that are below 4 million. So let's go ahead and get started. What do we know? We know that we need to find the sum of all the even valued terms. So we need the variable sum again. It's equal to 0. What else do we need? So for the Fibonacci sequence, we know we need one number plus a second number. So we'll say variable fib1 is equal to 1 because we're starting at 1 to get to 2. Then we're going to say variable fib2 is equal to 1. And then we'll say, call it fibbed is equal to, actually we don't even need to declare that one. We don't even need to give it a value, we just need to declare it. Actually it might not be a bad idea to make it a number out of the gate, so we'll go ahead and make it 0 for now. And then we're going to do another for loop, I think. I was going to do a for loop, but I think I'll mix it up since I did a for loop in the last one. Let's do a while loop. So we're going to say while fib2 is less than 4 million. Okay, we're doing this. See how, this will be fun to see how long this takes. Probably won't take very long at all, to be honest. So while fib2 is less than 4 million, we're going to keep running this loop. So we're going to create our fibbed is equal to fib1 plus fib2. Right? So now we have created our next number, which is going to be 2. So then you get into some weirdness, which we're going to do fib1 is equal to fib2, and then we're going to fib2, because you always need fib1 and fib2 no matter what, is equal to fibbed, which is the sum of fib1 and fib2. Now we need to find out if this is an even number. How do we do that? Well, it's very similar to what we did in the last one. In the last one, we checked to see if something was divisible or had a remainder of 0 when you divide the two numbers together. So what numbers are we going to divide to find out if it's even? How about 2? So we're going to say fib2 is equal to, not equal, is percentage 2 is equal to 0. Then we're going to say sum plus equals fib2. So that should be it, right? And all we need to do now is console log it. So let's go ahead and try it out. Console.log sum. So now we saved it. Let's go ahead and run it. I probably got an error, I'm sure. Hey, no, I don't know if this is the right answer, but could be. So if it's wrong, why don't you guys let me know in the comments. So there you have it. I don't know if I could think of a way off the top of my head to refactor this too much more. You could nest that if statement again, or not nest, but inline that if statement, I guess, but it's just kind of a weird problem, I think. You know, I'm going to leave it. You know, if somebody can refactor that better, I would love to see it in the comments or email it to me or whatever. I would love to see a more refactored version of that. Would love it. Thank you. Alright, so let's go ahead and create one last file here. We're going to save this. Call it test3.html. Save that sucker. Now let's see what the third problem looks like. Alright, so let's go ahead and jump into problem number 3. Prime factors of 13,195 are 5, 7, 9, and 29. What is the largest prime factor of the number? That's a big number. That's a really big number. Okay, so we want to find. So let's start by copying test 2. And we're going to wipe out all the stuff out of here again. So we're basically going to say, what is the largest prime factor of 600 billion, I think is that number. So let's go ahead and get started. So the first thing we need to do is set our number. So we're going to say our number, actually we forgot the variable. Our number is equal to this big old long number. Copy, paste. And we're going to do a for loop. You could do a while loop as well, but I like the for loop. So we're going to say I is equal to 0. We're going to say while I is less than our number I plus plus. And what we're going to do we should be able to we're also going to set prime factor equal to 0 right now, even though that's not it, but I'm just basically setting it up, making sure it's an integer, and then that way we can work with it without worrying about it being a string. So let's go ahead and do what we're going to do in here. So we're going to say if our number, and actually, now that I'm thinking about this, we don't even need this. You'll see why. Our number is, gives us a remainder of 0 when we divide it by I. Then we are going to say our number is equal to our number divided by I. And then after that, I mean, it seems really simple, but I think this might do it. Yeah, let's see what happens. Wow, this was way simpler than I thought it was going to be. Yeah. Okay, so now let me explain kind of what's happening here. Let's make sure this works first. So let's go ahead and reload this, inspect element. And yeah, well, no. Sorry, hold on. Let's go ahead and move that out. That's not really what I was going for. So let's go ahead and inspect this element. 6,857. So let's move this back inside here real quick. And let's see if we can get this thing to do what we want it to do. And we do. Alright. So as you see, it's kind of working through that number. So what it does is we feed our first number, which is that big old number it gave us, into our for loop. And we say for our number, go ahead, while our number is less than I, start counting up. And it counts up to I. And at each iteration, it sees if our number and I divided into each other gives you a zero remainder. If it does, then it takes that number and divides it by I. And that makes it our new number. What it does is it takes that number now, and our number is different now. So our number is now, not that number, it's this number. So what we're trying to do now is we're trying to see, okay, so when we divided our big number by 71, we got down to this smaller number, yet still very big, of something like 84 million or something. So then we go start iterating again. How many times did it have to iterate to that? 768 times. So 768 was divided into this. So we said, okay, how many times is it going to take to get to a smaller number? And basically what ends up happening is eventually we get to this number gets fed into here, and we never find a number that makes it divisible. So that makes it so it just keeps skipping this. It keeps skipping this, and it won't divide it again because it can't be divided anymore. And that makes it the largest prime factor that we could find. So I mean, that's it. I think we could definitely refactor this, but I think this video's ran a little long. So maybe I will revisit that in the next code test video. Hopefully you guys kind of found this enlightening. There will be a few more videos coming out here in the coming weeks about interviewing and some things to think about and to be prepared for, because it is, it can be extremely challenging, especially if you're not used to it. So yeah, I think the more you know, the more prepared you'll be. But be honest. That's my number one rule. Always be honest. Don't pretend like you're something you're not, because if you do, eventually it'll show. I think that's it, DIYers. Everybody take care. Thanks again for watching.